Hey there, Mr. Weaver here, and this is Topic 8, Lesson 5, Standard and Vertex Form of Quadratic Functions. After this lesson, you need to be able to write a quadratic function from a graph and from a table. You'll know you're successful after this lesson if you can use the leading coefficient and vertex to write a function in vertex form, expand, distribute, and combine like terms to change a function from vertex form into standard form, and create functions from graphs and tables. First, let's look at the two formats that we are going to talk about in this lesson. Vertex form is one format that we can write a quadratic function if we know the vertex and the leading coefficient. Here, for the vertex, instead of x and y, they use the letters h and k, and the leading coefficient is shown by the letter a. So in our equation, a, the leading coefficient, is going to be out in front of the parentheses, and then our vertex, h and k, you are going to plug those in. H is in the parentheses with x, and k is at the end. One thing I do want you to notice, h is the opposite in the equation versus the vertex, while k is the same. So it's going to be the opposite of h, same k. If we're thinking about the features that these go along with, h is the opposite of your axis of symmetry, while k is either your maximum or your minimum. Our other format is standard form. Now, this format, there's not really any special meaning here. It's just in order from largest exponent to smallest exponent. ax squared plus bx plus c. First, let's look at writing equations of the parabola from a graph. So to do this, first I'm going to write it in vertex form. I need the vertex and the leading coefficient. The vertex, as we learned in the last lesson, is the highest or lowest point. So here it's our lowest point at 4, -2. The leading coefficient takes a little bit more work to figure it out, but essentially you need to figure out how many units up or down did you have to go for 1 unit over. So it's almost like a unit rate. So if I go 1 unit over, how many units up or down do I have to go to get through the graph? I would have to go half of a unit up. If I wanted to keep it as a decimal, I could just divide that out. Anything divided by 1 is that same number. So my leading coefficient would be 1/2, or 0.5 as a decimal. Now, for my equation, I'm just going to plug those numbers in. Here's my equation. I'm going to take away the things I need to plug in. And for this, I'm going to change the colors of h and k. Now, to plug things in, the vertex, it's the opposite of h, so it would be -4, but the same k, so -2. And then your leading coefficient goes out front. So our equation would be f of x equals 1/2 times the quantity x minus 4 to the second power minus 2. That is our function in vertex form. I just took the values that I figured out and plugged them in. Now it's your turn. Pause the video. See if you can figure out the equation of the parabola in vertex form. Let's check. You should have found these values. So your vertex is -4, 2. The leading coefficient here is -3. If you go over 1 unit, you have to go down 3 units to get to the next point on the graph. When we plug those in, we get our equation f of x equals -3 times the quantity x plus 4 to the second power plus 2. Again, it has the opposite of h and the same k. So positive 4 and positive 2. Now let's write the same equation as before, but in standard form. So to do this, we need to take what we had in vertex form and kind of rearrange it so we get it in the format that we want. So first, in vertex form, it has that exponent of 2, which means it has x minus 4 twice. So whatever was in that parentheses, you're going to write it now twice. Then you are going to multiply those two binomials together. So x minus 4 times x minus 4. We get x squared minus 8x plus 16. Now that we've multiplied it out, we are going to distribute our leading coefficient to everything in the parentheses. So 1/2 times x squared, 1/2 times negative 8, 1/2 times 16. I end up with 1/2 x squared minus 4x plus 8. And then our last step, you are going to combine the last two numbers, your two constants. So positive 8 minus 2 is positive 6. Now we have our function in standard form, 1/2 x squared minus 4x plus 6. Now it's your turn. Pause the video, write the equation from before in standard form. Let's check. You should have got f of x equals negative 3x squared minus 24x plus 46. To get that, again, we expand it out, then multiply, distribute, and finally we get our standard form answer. As with the last chapter, if you want to double check to make sure you have the correct thing, you can always use Desmos to see if you get the same parabola both times. The vertex form parabola and the standard form parabola should be in the same location if they are the same and your solution is correct. Last, let's look at an example of writing an equation from the table. So for this one, I'm just going to use vertex form because that is the easier form as we just plug in numbers. So here I have my table. If we think about what is happening in a quadratic or in a parabola, it is either going up until it gets to a maximum and then goes back down, or it starts going down until it gets to a minimum and then it goes back up. So either way, we need to look for the vertex. If I look at my numbers, it goes 5, 7, 5, negative 1, negative 11. So notice it was going up and then back down. So if I can find that maximum or minimum, then I can also find the vertex. So 7 was my maximum here. That means that is what's with my vertex, negative 2 and 7. Now to find the leading coefficient, how many units did it go up or down for every 1 over? So negative 2 to negative 1 is just 1 over. So what did it do? It went down 2. Now plugging those in, I would get negative 2 times the quantity x plus 2 to the second power plus 7. Again, opposite of h, same k. If we want to use Desmos, we can always add a table and recreate that table in there. So it was negative 3, negative 2, negative 1, 0, and 1 across the top. And then it went 5, 7, 5, negative 1, negative 11 across the bottom. You can see where the dots are and how the graph might look. You can always click and hold and turn the line on, and it's not that perfect curve if we had typed in the function, but you can kind of see how it would look. So 7 was my vertex, that maximum point, and it's halfway between my other two, so I know that that's the middle. And then if I want to use Desmos 2, I can double check and type in my equation do I get the same parabola? And it went through all the points, so it must be the correct equation. Now it's your turn. Pause the video one last time. What is the equation from the table? Let's check. You should have got f of x equals 1 times x minus 1 to the second power minus 8. Your vertex is 1, negative 8. That negative 8 was your minimum. The leading coefficient was positive 1. If you go 1 unit over, so from 1 to 2, it went up 1 to go from negative 8 to negative 7. So the leading coefficient was positive 1. In this lesson, we learned that quadratic functions can be written in two formats, vertex form and standard form. Vertex form involves using the leading coefficient and the vertex, and then substituting those values into our equation, f of x equals a times the quantity x minus h to the second power plus k, where a is our leading coefficient and h and k are the coordinates from the vertex. H is the opposite of the x coordinate for the vertex, while k is the same as the y coordinate of your vertex. Standard form took a little more work to figure it out. It is ax to the second power plus bx plus c. You find this by taking vertex form and then expanding the exponent into two binomials, then multiplying it out. Then you distribute the leading coefficient and finally combine the constant terms, and you end up taking vertex form into standard form. Both formats are useful, and they can tell you different things in context, which we will look at in the next lesson. After this lesson, do you now know how to use the leading coefficient and vertex to write a function in vertex form? Can you expand, distribute, and combine like terms to change a function in vertex form into standard form? And can you create functions from graphs and tables? If you're not sure about these things, go back and look at the different examples to learn where things are located and how to write our equations from graphs or tables. And that's the end of lesson 5 on vertex form and standard form of quadratic functions.